Hi everyone. So today I will walk you through the POC that we have built around converting credit files into structured data. The core problem we are solving here is the credit reports are usually PDFs which are unstructured and it's difficult to directly use them for the downstream analytics. So the goal of this POC is simple, like take those PDFs and convert them into the structured curable data that can directly feed into the data marts. So this is what we are starting with. This is an actual CIBIL credit report PDF. Now, if you look at this, you can see it has a lot of information. At the top, we can see the consumer details like name, date of birth, contact information. Then we have a CIBIL score and different scoring factors. Below that, we have identification details like PAN, phone numbers, addresses, and then the main part, the account history. This is where the main loan accounts are listed, each with the details like balance, EMI, and payment history. Let's take a simple example. The inquiry section at the bottom. Here, it looked like a clean table, like member name, inquiry date, purpose, and its amount. But when we extract this as a plain text, what we actually get is just a sequence of text. There is no clear column separation. So the system has no idea what is the member name, what is date, what is amount. So naive text extraction doesn't really work here. What we need is a way to understand the structure of the document, not just extract the text. So this is again a loan statement from a housing loan in this case. Again, you can see it's got a very specific layout. Customer details on the one side, loan details on the other, the disbursement schedule, a financial summary table, and a transaction history. Same problem, structured visually but not machine readable in the useful way. So these two documents are what we built our pipeline around. Before I show you the architecture, let me explain our core approach in the simple terms, because this is what makes our solution different from just doing a basic PDF text extraction. The key insight is that these documents have a visual structure. There are boxes, there are table boundaries, there are section headers, there are rows and columns, and that visual structure carries some meaning. So instead of treating the PDF as a wall of text and try to reject our way through it, we first convert the PDF into what I would call a layout map, essentially a representation of where every piece of content sits on that page, what kind of element it is, and how the elements relate to each other. On the top of that layout map, we then apply document specific parsing logic. So for a credit report, we know exactly where the consumer information sits, how the account blocks are structured, what the DPD history row look like. And for the loan statement, let's say we know the first page has a two column layout, where to find the disbursement table, and how the financial summary matrix is organized. This means our parser is not a generic tool. It's a purpose built for these document formats, which is why the output is so clean. Let me show you how this all fits together end to end. So before I go into the full technical setup, let me show you the big picture in the one view. Four simple stages. Ingestion at the top. This is where the PDF lands, whether it is a CIBIL report or a loan statement. It goes into a storage bucket on the Google Cloud. The moment that file hits the bucket, an event fires automatically, and that event kicks off the parsing stage. This is where the heavy lifting happens. Our parser service picks the PDF, reads its layout, the tables, sections, and the structure of the pages, and converts everything into the structured JSON. Think of it like it going from a visual document to a machine readable format. Now that JSON then flows to the transformation stage. Here we take that single JSON output and break it into the clean normalized tables. So a credit report does not just become one big JSON blob. It becomes a separate table for the consumer details, accounts, inquiries, payment history, and so on, each with the proper data types. And finally, that data lands in the big query, like our analytics layer. External tables point directly at the output file, so the moment transformation is done, the data is queryable. The whole thing from the PDF upload to data in the BigQuery is fully automated and takes just few seconds. Finally, this data is exposed to BigQuery, and now instead of the PDFs, we can directly query the structured credit data using SQL. Now, let me actually show you the full pipeline flow. Like the PDF goes in and then the JSON comes out, and finally the BigQuery has the data. This is our raw PDF bucket. This is the entry point of the entire pipeline. Right now it is sitting here empty and waiting. The moment something lands here, everything kicks up automatically. So now I am going to upload the CIBIL credit report that we saw at the beginning. File is uploading and it's in. Now behind the scenes, the moment that upload completes, GCS fired an event and it sent straight to our parser service on the Cloud Run. And if I replace the process JSON bucket, that's our output file. Let me open it quickly so you can see what our parser actually produced. This is the structured JSON that come out of that PDF. You can see the customer info, the accounts array, the inquiries array, and all the fields we talked about earlier. This is the clean data. Now this JSON will be breaked into the separate tables like accounts, inquiries, customer informations, and so on. Each one gets written as a Parquet file, which are like basically the efficient for the analytics. And let me show you that also. Here are our Parquet files, one per the table, like credit accounts, credit inquiries, customer infos, report metadata, and all that. All that sitting here ready to be queried. Now the BigQuery has the external tables pointing at these exact folders. So these files are already queryable right now. As you have seen the execution of the pipeline, let me actually show you how the data is parsed and stored it in our tables. Here you can see the data from the PDF is populated in the different tables. Let me actually query the data and show you the actual results. And there it is. So this is the customer table where we can see the information like full name, date of birth, gender, and etc. etc. Let me validate this information with the PDF that we saw earlier also. Yeah, so this information is correctly extracted and parsed and stored in the final table also. Let me query the one more table, inquiries table. So in this table, we can see the LN inquiries, just like the PDF showed, where here we can see the lender name, the inquiry date, purpose, amount, and you can see the derived columns we just added, like the date since inquiry, whether it is within 30 days, 90 days, or 12 months. So let me show you the PDF once again. Yeah, so here you can see that these are the exact 11 rows that we extracted and stored it in the final table, and all these values are extracted correctly. There is no error in the parsing or extracting. Yeah, so these are the fields that can be used further for the downstream analysis, and we have just pre-computed it for the further analysis. So let me just take a step back and summarize what this means practically. What we have built here is a pipeline where a PDF comes in and within the seconds we have clean structured data sitting in the BigQuery, which is ready to be queried and ready to be used in the dashboard and further analysis. These are not the clean templates. CIBIL reports actually have the accounts data spanning across the multiple pages like weird table layouts and the DPD histories embedded in the odd places. Similarly, the loan statements can have the complex two-column first pages, multi-line transaction descriptions, and we have built this parser particularly to handle these realities, not just idealize the clean inputs. Today, we have built this for the credit reports and the loan statements. But in the future, if the architecture is designed so that adding a new document type, let's say ITR documents or the bank statements, it's just a matter of building a new parser plugin. The pipeline, the infra, and the storage model, everything, all of that remains the same.
Before I wrap up, I want to show you the actual comparison side by side. On the left hand side, you can see the original CIBIL report PDF, and on the right, we have the JSON output that we get from our parser. As you can see, the customer details at the top, these are the exact that we got in our output. Also, the CIBIL score, here is the 734, and that's what we got in our output. Also, the scoring factors, these are the same that are mentioned in the PDF. Also in the account section you can see the income tax ID, universal ID. These are the same exact details that we are getting in the output. Let me actually scroll down to the account section. Yeah, so here is the account, Bajaj Finance, where this is the personal type loan, open date, report and certified. We will cross verify this with the actual output. Let me scroll down. Yeah, so these are the details that we got in the output. These are the exact that are mentioned in here, like the Bajaj Finance, the open date, type of loan, also the EMI amount, current balance, high credit amount. These are the exact that we are getting in the output. These are the same account and member name, and every field that was inside the PDF, now we have this with the named key with the typed value. Let me show you the one more section, the inquiry section. Yeah, right here. Yeah, in the PDF you have got the 11 rows like the lender name, date, purpose code, amount. That's it, it's just a table. And if you see on the right, we are getting the 11 rows as well. These are the same values that are in the PDF, like the Incred Finance, Bajaj Finance, IDFC First Bank. These are the exact same values that we are getting in the output. These are the same 11 records. Now I have swapped the right side to the actual BigQuery tables because this is what that will be used in the downstream systems for the analysis. Now we have the same data but in the rows and columns, like every account is the one row and every field is the one column. Let me point out something specific. You can see we have the 4 accounts in the PDF. One, this one is second, third and 4, and we are getting the exactly 4 rows in our actual table with the details like the account name, account number, account type and open date. These are the exact same details that are mentioned in the PDF. You can see that also. And let me switch back to the inquiry section. These are the 11 rows that are in the PDF. Now we have that in the as a table format. So now we have the PDF data in the form of table.